Dear, dear students, see the next question from 11th standard unit and measurement chapter. The need based question number 7. See that a metal sample carrying a current along x-axis with the density, that means current density, that is Jx. Okay, usually the current density is represented by the letter J along with the x-axis, so Jx is subjected to a magnetic field Bz. So that current to producing the magnetic field along in Z direction. So now they are asking, the electric field Ey is developed along y-axis is directly proportional to Jx as well as Bz, current density as well as the magnetic field. So we can get some constant. That constant SI unit is asking. Okay, so it is purely related with the plus 2. Okay, anyhow it is we are finding the unit and measurement, but the concept from the plus 2. But you know, in the 10th standard you can get just a common idea about the current direction as well as the magnetic field direction. So according to that we know that. So we know, for example, let us take it is the x-axis, along x-axis. So in the along x-axis, a metal sample carrying a current along x-axis. So it is a conductor. Okay, the conductor having the current, the I, in the x-axis. Okay, so you know very well. Generally, here it is the current direction. Here the magnetic field will form. So up and down the magnetic field is there. So let us take the producing the magnetic field is where? That is Bz. So this is x-axis, this is z-axis, and this one y-axis. So here the current density along x-axis, so that is we can write Jx. Then the magnetic field along z-axis, that is we can say Bz. Here, because here the magnetic field will form like this. Okay. So it is a current density, current density, because the current density is nothing but J is equal to I by A. Okay, wow. So ampere, current passing through unit area, that is current density. That is J is equal to I by A. This is along x-axis, so I divide by A. Okay. Then it is a magnetic field. The magnetic field here perpendicular to the current direction. Okay. So this is the statement. Then after that, see that the electric field Ey, that is along what? That along the y-axis, the electric field is developed. That is Ey is developed. Okay. So please listen carefully. That developing electric field is directly proportional to Jx and Bz. Jx and Bz. Therefore, what they are asking? They are asking unit for one constant. Here one constant will come. That unit they are asking. So we can write that is Ey divided by Jx Bz is equal to constant. So that constant I can write as Jx Bz is equal to constant. Let's take the k. So this k unit only they are asking. So what about the unit for E, J and B? Like that we are going to find. Okay, so please listen. I want to explain in easy way. First you simplify this E divided by B, that unit generally. So that electric field, this is E is the electric field, B is the magnetic field. Okay, so let's take electric force and the magnetic force relation. Okay, I can equate this. Actually electric force, okay, electric force, actually we can write that is electric force, that is F is equal to E is equal to electric field is equal to force acting per unit charge. This is one of the formula you will be studying in electrostatics chapter in 12th standard. Electric field is equal to force divided by unit charge. Therefore electric force is equal to EQ. So this is one formula. Then another one, magnetic force, that is F is equal to BQV. So this is already you studied in 10th standard also. Force experienced by the what is it, charged particle. So F is equal to BQE. So we can compare, we can equate these two equation. We can write EQ is equal to BQV. So here let me see that Q value Q is cancelled. Therefore V is the velocity. Therefore V is equal to E by B. So I can write V is equal to E by B. So E by B I can write V. So the next step, therefore K is equal to E by B. E by B we can write, that is velocity divided by here the current density, that is Jx. Now very simple. Velocity unit you know, meter per second divided by current density. Current density actually what is the formula? Current density means current passing through unit area. This is current density. So please listen. Ampere, I is the ampere. Ampere unit, I is the current unit is ampere. Divide by, this is cross sectional area. Cross sectional area unit is, that is meter square. Ampere per meter square, that is the current density unit. Okay, see that this is cross sectional area, this is ampere. Okay, ampere per meter square. So I can write Jx is ampere per meter square. Therefore see that already meter is there, meter square is moving numerator, become meter cube. Then s power minus 1 moving down, this become s. Then already A is there. So see that we can get this constant unit is meter cube divided by ampere second. So this option is matched with meter cube divided by ampere second. So option B is correct. Okay, thank you.